Okay. Hello everybody, my name is Sarah. I would like to introduce you my thesis plan. The title is Improving Centric Web Application Visualization Capabilities. So before we going to the objective, I would like to introduce you about the Centric itself. So Centric is the first remote sensing web application that designed to semantic enrichment query, especially for Sentinel to imagery data. So the basic idea is like Google Earth Engine, but in Google Earth Engine, the user required to have some programming skills. But here we change the programming part into some block here. Some building blocks that the user can use some modeling or create some modeling of the semantic enrichment, and then they also can choose the location of the area of interest and change the temporal subset, which means the period of the imagery recording. And the last part is the inference, which user can get the imagery data as raster maps. They can just use directly from the web application, but they can also do some further analysis in their own software. So the basic idea is like the processing is on the fly on the web application, but they also provide some visualization here. And I want to focus on the inference, which also provide the preview mode of the raster image. So here, after the user can create some model, inference model, the result of the preview mode is something like this. As you can see here, the result is still on the default mode, which the legend is 0 with a darker color, and then the highest number is in white color, so it's not quite following the cartographic principle. Based on these findings, my objective for my thesis is to develop a set of tools and capabilities of the Centric application, breakdown into four aims. First is creating some cartographic tools, and then determining the threshold of the raster workflow and the raster map, and to improve the image map, so it's not only like the raster image, the raster maps, but also include some additional cartographic information, something like that. And for the last one is user testing, which we allow the current user of Centric to evaluate the improving part. Here, the method that I will use to create the tools, the cartographic tools, I will use JavaScript with the Ember.js framework to create the front end part. And then for the threshold of the workflow, it's analyzing the limit spreading, which the workflow that makes the user understand intuitively about how to creating the visualization part, and which the bare minimum of the user can understand the workflow. The image map also using the JavaScript programming, and for the user testing, I would like to contact the current several user of Centric, and then asking them in interview or some question. So this is what I have been done. So right now we're still in the discussion about determining the object, but we have been pinpointed to two aspects. The first is raster map, and then the preview mode of the interface. And then after that, we will doing some user testing, and if they have something that should be improved, we can go back again to what of the object. Expected result is the tools here. The cartographic tools make some menu maybe for the summology, and the layout is just for giving the title or changing the some additional information here. And then this set of image map from the Sentinel data, so we can know which the improvement between the previous of the cartography without using cartographic tools and after the cartographic tools. And for the result of research settings should be in right then feedback. Thank you.
Thank you for the presentation. The discussion, please.
Yeah. Oh yeah. Oh, okay. Thank you. So for the user itself, right now it's mostly people inside the Salzburg University because it's a program based on the Salzburg University right now. They're still on the developing process. They're students, some of them, and researcher. But somehow, actually, CentuCube will have more public, broad audience in the future after the system is quite stable to be announced to public. Thank you.
We kind of automatically determining what's the best visualization method for specific type of data. Like if you get depending on the grain, for instance, or the location, do you say different cross scale or? Yeah, so I have some idea because they use the cyan categories of the spectral, and when the user want to have the sentinel data with the under that categories, I would like to make the option for them to follow the similarity of the categories, and when they use the continuous data, it should be expressed in the data. Like before, a 0 is in dark color, it's supposed to be in black color. Something like that.
Some more questions? If not, thank you very much for presentations. And we also finished the second session. So we have, let's say, 5 minutes for a short break, and then we will continue half past 12, please, and we will finish the third session.
Ten to prostě přepnul, jak mluví z toho a to vytrhnou.
Okay, so it's time. We need to follow the schedule. Finally, we sort out this annoying sound, so it's maybe better for you. We have actually 4 more presentations in the schedule, so Magda is online or not?
Yes, I am.
Okay, great. So I will stop.
Great.
So you can share the screen. Are you sharing the screen?
Yes, I'm sharing. That's my background. I'm just waiting to start the presentation.
You can put the presentation there, and I think we are mostly all here, so you can start, Magda.
Okay, good afternoon, everybody. Today I would like to present to you the progress on my master thesis, which are called Web-Based Solution for Visualization of Uncertainty of Data from Honeybee Winter Loose Monitoring. And my supervisor is Dr. Bruce. So the main objective of my thesis is to create web application which will visualize uncertainty of the data from honeybee winter loose monitoring together or separately with the main result of this monitoring, which are losses. I'm also focusing on the nature of the data and a context of the target audience, which are the people which participate in the honeybee winter loose monitoring. And in the final stage, I will test the created visualization on this target group, so on the people which participating in the monitoring. And I will try to find the best one and optimize it in a context of decision making. Okay, so we can ask why we want to visualize the uncertainty. The reason is really simple, because the whole project, at least in Czech Republic, or the whole monitoring, works on a concept of citizen science, which means that beekeepers giving voluntarily their data to us as scientists, and then we present them the results. The problem of any type of crowdsourcing data is that then we don't have always the same participants. These participants or respondents don't have the same number of beehives. And also we have a problem with spatial distribution, which is changing every year, and size of spatial units, because the winter loose monitoring, it's geo-coded to zip codes of Czech Republic. Here you can see how a number of respondents and their spatial pattern is changing through the years of survey. And on the top right corner in the graph, you can see that the higher number of respondents not necessarily mean the higher number of the beehives that are represented in the monitoring. Luckily, we can. So this might show that the data are not scientifically correct, that this is not the right scientific sample. But luckily, we have also sourced from Ministry of Agriculture of Czech Republic, which allows us to calculate some statistics. So we can calculate mainly 2 metrics, representativeness, which is how much of the beehives in the monitoring is there compared to the data from Ministry of Agriculture, and stability, which basically just saying us if this zip area is stable, if we have continuous data there or not. But it's not telling us if there are the same respondents. But both of these things is good to take in account, or when we want to make some decisions about the losses of honeybees, it's good to filter the data a bit according to those 2 statistics. So far, the results of the monitoring are presented with 2% of representativeness at least, but the stability wasn't taken in account really. Another limitation that we have is a static presentation, because as I already mentioned, the zip areas quite vary in a size, and if we have just one scale, it might be possible that the uncertainty might override the thematic information which we want to show. So if we decided to do something more interactive, we can add more information and more details which might be interested for the beekeepers. Here you can see my present workflow and my future workflow of the thesis. So far, I'm still in a stage of state of art and data processing, because there's a lot of things to discover, especially on the web, on the side of how to visualize uncertainty on the web. But I already select some visualizations which might be worth to try, and I did first tries on make them on the web and make them interactive. So from the state of art, almost all the articles about visualization of uncertainty are coming back to this one from Van McAchen, which divides the uncertainty map to 3 categories: map pairs, sequential presentation, and bivariate maps. On the other hand, we can do that somehow on the web, and we have kind of 6 possibilities how to show different years of study, and this can be 5 of them can be also applied on showing uncertainty and the thematic layer. We can do toggle, we can do swipe, side-by-side maps, or we can just show the change between 2 years, or we can, of course, animate it, and we can combine those methods. So the final application which I want to make need to have these attributes and need to be need to give us a possibility to select by year, and need to have a filtration by representativity and by stability. Also should allow us to zoom in and zoom out. That's mainly because we want to try some visualizations which need that and need to be easy to use. And according to state of art, I also want to include the kind of a learning tour which should explain a bit more beekeepers why there is the layer of uncertainty. That's all from me so far. Thank you for your attention.
Okay, thank you, Magda, for presentation. And, okay, Magda, it seems that everything is clear. Everything was presented, everything is understood. So it means that we can stop the presentation. Thank you for presenting, and greetings to Trondheim, and we will see you soon, hopefully.
Yes, I hope so.
Bye-bye.
Bye.
Okay, next presenter on ground.
Hello everyone, my name is Andrzej Mikowski, and today I'd like to talk about my master's thesis, which covers the topic of analysis and modeling of landscape suitability for beekeeping. My supervisor is Dr. Lambros. I'll quickly sum up the goals of the thesis. The main goal is building a land suitability model for beekeeping. The area of interest is the whole Czech Republic, and the scale should be around 10,000. The important part of the thesis will be expert calibration of the model. That means finding out which of the different aspects or data sources are most important for beekeeping. And using this calibrated model, we can then conduct a landscape assessment, which gives us the final figures of the suitability index. Then, of course, I'll do some interpretation of the results and visualize these results within a map. I'll get to that near the end of the presentation. From my literature review, I found a few studies that cover a similar topic. They've taken place in Italy, Turkey, and the Philippines. course, in these areas, the factors that contribute to the suitability of the landscape are different than in Czech Republic, and that's why we are conducting this study. But what I looked at is data sources that they had used, and as you can see, all of them used elevation, land cover, distance from water, and distance from roads. But some studies have used more factors regarding the terrain, for example, so aspect and slope, and some other studies have used more climatic variables, for example, a few different data sources in their calculations. So I used this knowledge, and based on this and based on the available data sources to me, I've assembled my final list of data that I plan on using. First of all, is the cost questionnaires. That's a monitoring of the success of bee wintering. We have 7 years of data available. This study has been running for some time now. So that's one of the basic data. Then I'll be using a digital elevation model. In our case, DMR of the 5th generation. From that, I can, of course, derive the slope and aspect of the terrain. And then I'll be using climate conditions from the database WorldClim. I'll be using annual temperature, precipitation, solar radiation, and wind speed. Data sources, I have 2 options for land cover. We have the S3 land cover 2020 and the ESA world cover. They are both derived from the Sentinel imagery. So they are quite similar. They have a little bit different categories. They have about the same amount of categories, and they are both in 10-meter resolution. It's really great that we have these data sources available now, because 2 years ago, the best data could be, for example, corridor cover, and it's not so good. And this is much better than that, for example. Then I'll be using a few layers from the Copernicus program. They have quite a wide range of data available for this kind of analysis. Again, it's derived from the Sentinel satellite imagery. And again, it's in quite good 10-meter resolution. So we have forest, grassland, water wetness, and some vegetation phenology and productivity. That means, for example, the length of the crop season, when the season starts, when the season ends, and a few different parameters similar to that. Then I'll be using OpenStreetMap. I'll use the layers for roads, rivers, and lakes. It's quite straightforward. And I plan on also having a look at the Data 50. There are blocks of buildings. Of course, we already have the build-up area in the land covers, but I want to have a look if that corresponds well together, or if there are any differences, and in case there are, take care of that somehow. And actual topic right now is questionnaire for beekeepers. This weekend there will be a seminar right in all modes for beekeepers and other people interested in the subject, experts from this field. There will be around 200 participants, and I'll use this questionnaire to ask them what they think are important factors for suitability of the landscape for beekeeping. So this will give me a great place to start with which factor is the most important, which might not be so important in the end, because I'm not a bee expert myself, but they are, and I hope to get some knowledge from them. Also, the questionnaire will be sent out to about 2,000 participants of the annual questionnaire study that is done every year. So I hope to get a solid amount of responses and good data. So my basic workflow will be all conducted within ArcGIS Pro. I'll be prototyping my model. I'll be trying using fuzzy approach and multi-criteria analysis. And throughout the process, I hope to consult with the beekeepers, although the main consulting could be the questionnaire I just talked about. And also throughout the process, I'll be calibrating the model, which might be the most difficult part because it is hard to tell what weights to give to each of the factors, as I'll have quite a number of factors, as you have seen. The final results will be indices for suitability and for risk of the landscape for beekeeping. I will interpret them and visualize them within a web map application. The main target users will be beekeepers, and the main layers will be shown there. And it will also contain a suitability modeler, which is a widget within the web map that allows the users to assign different weights to different factors. So, for example, if the beekeeper thinks that distance to water is more important, and he doesn't care so much, for example, about the slope, that the terrain is higher slope, he can do that within this modeler, and it will give him a bit different results than from the basic default. Then also there should be a 5 kilometer analysis, because the bees can fly about 5 kilometers. So he clicks within the map, and it will calculate for him the sum of the suitability in that area, and he can decide what's the best place to put his beehive. So last slide, this is the first map that I created based on some of the factors. I just gave them some values that I thought could be good, and I just wanted to show one of the first results. So this is what some of the results could look like. It's just for a small area. One of the first attempts how to work with this data. So that's all for me, and if you have any questions, feel free to ask me.
Thank you, Andro, for presentations. The question.
Can I ask about the last loop? Sure. So the green areas that are suitable for
More suitable
for placing the hive.
that would be
And do you include the localities of the hive are already there?
Yeah, I wanted to use that, but it's hard to work with the data because it has to be for some security and privacy measures. It has to be aggregated to bigger units. So I don't know exactly where the beehives currently are. So that makes it troublesome.
Yeah.
But I want to work with the data. Well,
You said something about 5 kilometer buffer. So if you use, let's say, 5 kilometer hexagon grid, and just make those where the beehive already is, like a constraint. So yeah, so here in this cell, there already is some kind of beehive.
I only know that the beehive is within a certain position, and that's what I can work with. But that could be quite a big area.
I have a question. Do you consider elevation?
Yeah, definitely. I'll have some limits. I'll try to ask the beekeepers if they think that beekeeping is impossible above certain elevation, for example, or what is the ideal elevation.
Target response to the location. A lot of meadows are it's hard to fly for.
And too windy, for example.
So I don't see there. So
Yeah, I
that's
just
my question.
some of the factors. All of them.
You also take into account atmospheric parameters like the air pollution or precipitation.
I'll take into account precipitation for sure, and also the solar radiation, so the amount of sunlight. I was thinking about some quality of air data, if you mean that. And we'll see if we can get some data that's good for analysis.
If I may, one very short question. The buffer around I suppose the green thing is buffer around rivers.
I have the lines are rivers, and the areas are buildings, so settlements.
Yeah, but there is a, let's say, green buffer around the rivers.
That just because I said it's good to be near river, so the suitability is good there.
Yeah, but what is the distance of the buffer from the river?
Here I think I like 300 meters approximately.
Okay.
I need to figure out the exact values.
I'm thinking if it's not too close to the river, you know, in case of some floods or something.
Yeah, that's a good point.
Okay, all right, it's over. So thank you for presentations, and we have last two presenters. Please, it's yours.
So, hello everyone, I'm Yura from the CDE program, and my master thesis topic is about the portrayal of likely climate change impact on beekeeping based on Earth observation data, and my supervisor is Dr. Jan. So I would say the main research area in this field is not completely blank, but it's almost blank. So the objectives of this research is mainly to explore the potential of Earth observations data for beekeeping in the context of likely climate change, and we will finally develop somehow a platform for the beekeepers to support beekeeping, and also try to portray the likely climate change impact using maps, graphs, animations, and even videos. So the main approach would be to integrate Earth observation data and also beekeeping data crowdsourced from beekeepers all over Europe. And this will be done in a large spatial scale, which is within the whole Europe, and also a relatively large time scale, which is during which the likely climate change could happen. So this is the softwares would be used. The most important one and the main one would be Google Earth Engine, which is the software will be used to develop the web application. It is a geospatial processing service powered by Google Cloud Platform. So it's very strong, they have petabyte catalog of satellite imagery, and it's all freely available. So yeah, that's also why we chose this one. And also Google Earth Studio, which will be used to visualize the final results as videos. And of course, as some other softwares like Google Earth, ArcGIS Pro, and also some coding software and graphic softwares. So this will be the data source. The first part is observations from Google Earth Engine data catalog. So these variables is the ones that we found, according to expert knowledge, would affect the living environment of honeybee. So including some climate conditions like air temperature, precipitation, and also some vegetation, land cover, and also some air pollution variables, including sulfur dioxide and particle matters. Except for those data sets from the Google Earth Engine, we also have the data from Copernicus Land Monitoring Services, also freely available. So these will be used as auxiliary data sets in the process of identifying risky areas. And of course, beekeeping data, which is crowdsourced from the beekeepers all over Europe, including Denmark, Sweden, Ukraine, and Czech Republic, of course. So this will be the workflow. We will start from the Earth observations. The variables from the Google Earth Engine will be filtered and visualized through the web application, and this web application will be targeted to the beekeepers to support beekeeping, and the data. Oh, sorry. And the data will come from two parts. One is from the other data sources, which is not used in this web application, like the Copernicus land monitoring services, and also data derived from the web application, which we already processed. And combining these two sources of data, we will identify the risky area, like because of likely climate change. And this will be integrated with the beekeeping data and trying to do some like overlay analysis to find the link between these two. And the final results would be, first of all, the web applications for the beekeepers to see what's going on. And also some analysis results visualized through maps, graphs, animations, videos to portray the impact of likely climate change on beekeeping. So that's it. If you have any questions or any suggestions on the design of the web application, please tell me.
Thank you for the presentation. Some comments?
Have you got an idea in which software or which map library you will use for the map application or developing?
The web application would be mainly developed through Google Earth Engine. They have kind of API for web application development, and there was a example we found. It's this.
But if you have an idea in which map library you will develop an output for this, the final application.
You mean this?
No, this is a like prototype.
This?
Sketch, yes.
You can,
And the final application.
You can make sure the climate engine if you want.
Yeah, the climate
Click
engine.
on it and
It's powered through Google Earth Engine also, so I think it's developed through the API.
Okay, so you will follow the Google Earth Engine API?
Yes,
okay,
yes,
okay,
yes.
I got it.
So it's like something like this.
Okay.
Yeah, this will be somehow the final result of the web application, but not. I guess there would be a time slider instead of the time period. Yeah. Any other? Yes, please.
Have you considered using newer data? Because we have lots of stuff which is okay for history, but for example, it's 2008 and 2009 already. So if you consider using that.
The thing is, we are trying to cover as much as time span as we can. So and the spatial scale is large, so it's not very precise. We're not focusing on the only one country or one region, so it's the whole Europe. So here I think the precision of the data doesn't matter that much. So if there are new data available for that, like if the time span of the data suits the research, I think we will consider using that. Yeah, of course, but if the new satellite imagery data, let's say it's just from 2018, then it just doesn't suit, because in this short time period we cannot discover any likely climate change. Yeah, thank you.
Perfect. Thank you. Okay, thank you.
Okay.
And the last, Renato, please.
Thank you everyone. My name is Anatole Derino, and my thesis is not on beekeeping, like it was. It's, so as you can see, digital twins in the context of disaster preparedness, so not the whole disaster cycle phase, but only the preparedness and mitigation phase. Specifically the fusion of Earth observation data through GIS and game engines like Unity. So the aims of the thesis are to assess the current state of data fusion methods, that is how to integrate data all sorts of data into one game engine, which we can use then to develop a 3D application, especially XR. So XR, which includes virtual reality and also augmented reality, like Pokemon Go on your phone. Then lastly, present a workflow and a set of recommendations. So sort of advices to people who want to do the same thing later on. A bit of context. So with the ever-increasing amount of data available and the quality of the software we have, it's now the perfect time to start studying this. And not only that, but also new software that are being released, such as the ArcGIS SDK for game engines. So it was released like a few months ago, and so it's really nice to be able to work on sort of leading edges technology and also some related experience. It's about finding synergies between the work that we are doing at other places. This is where we stand right now. So you can see that in terms of disaster response, it's mostly focused on the post-disaster event, so responding to an event. And we want to be on the right here, where we prepare for upcoming events and prevent them from happening. So this is aims at moving from this disaster response phase to prevention, as you'll see in the next slides. But before that, data sources and formats. So we use elevation data, very high resolution elevation data, to model floods. Floods, which is a type of disaster which will be used in this exercise, coming from satellite imagery like Sentinel-1, Sentinel-2 also, which could be used also to provide a base map for the visualization. And lastly, city building data, so Tokyo, Helsinki, or Rhodes. Can be any city or really, because we have this sort of semi-automated pipeline for the processing. Yeah, so CityGML is the formats we ideally want to work with because it's the best one. However, it's very complex and not directly supported by Unity and other tools. So we may have to convert them to FBX using like FME, so data interoperability software. And the goal is to get a level of detail 1 data because we don't need more detail than that for the modeling, but we might want more for the visualization. So the workflow integrating the data into ArcGIS Pro, which is the tool we use for the modeling. So flood modeling, either inland or coastal modeling. Then simulated disaster events, so floods in this case. And then integrate the data using this Maps SDK, which I mentioned, which is very new. So it's very exciting to be able to explore it. Then lastly, we get it into Unity for the visualization. So we'll try to find the most suitable way of representing the data and most accessible way also for, let's say, it can be for disaster preparedness for crisis managers, so they can have a map of affected buildings and the areas which are safe, which could be safe and not safe, or for the citizens, like finding evacuation routes, which would be in the outputs. So, and then this is just an example visualization of London, where you can see the flooding with which is integrated with the city data. So we aim to reproduce something like that, but with more better quality simulation, not just sea level height, and also map affected buildings. So we can imagine a change of color for the affected buildings from red to orange together. And on the right, an example AR application. So this is Google Maps. You may have heard of this AR mod, but you could imagine something like that for the evacuation routes. So which way to take from an affected area to a safe area. Safe areas which can also be mapped. As you can see here, this area will be safe. So the outputs, applications, possibly with user testing and feedback, but the focus is not really on application development, just would be nice to have. Unity specific development nodes, so Unity uses, for instance, the C# modeling language, scripting language, So we can maybe produce a few useful open source scripts out of that. The data fusion workflow, because as I said, it's still very new, and we want to be able to have a pipeline to get the data from any city and then model specific disaster events. And then the conceptual analysis will be what's the point of doing so? Is it useful and is it worth it? Thank you for your attention.
Thank you for the presentation. Perfect. So, question, Renato, please.
I would like to just ask if yesterday's presentation from Bene Capital were somehow inspiring or helping to.
Yes, definitely. Like they model evacuation routes, but within a building. So with BIM, we want to do the same for entire city. So we have to use different types of data, like geolocation data. And they also have developed a system to integrate web app services into Unity. So I tried to contact them to see if we can also use that, because it would be very cool to have that web app services. It's a very versatile services.
So it looks like that we are done. Thank you again, Renato, for presentations. And thank you all for presentations. Actually, we are on time. We have 2 minutes left.